All right, so today we're doing integer word problems. So this is our last section, and I know how much you all love word problems, so this is my gift to you. It's a way to send off the chapter. I know how much you love them. Okay, so let's talk about, one of the big things that we're going to be talking about is consecutive integers in some way. So does anybody know what, let's talk about what consecutive means first. Anybody know what consecutive means? Stacy.
Like one after another.
Good. One after another, right next to each other in some way. Perfect. Okay. So, is it safe to say that 1, 2, 3, 4, and on, those are consecutive integers?
Yes.
Good. Okay. Now, how about consecutive even integers? Consecutive even integers. Marcy.
They're pretty much the same thing, only they go by twos.
Good. Go by twos. So 2, 4, 6, 8, and on and on and on. Correct? Okay. Can you guess what I'm going to ask next? That's good. Okay. Consecutive odd integers. Okay, so who can tell me what they think consecutive odd integers are? Akashni. Good. 1, 3, 5, 7, 9, and on and on and on. So there are multiple ways of doing these problems. We're just going to get some practice with these types of problems. There are multiple ways of going about these, one of which involves setting up an algebraic expression to get from one number to the next. So let's go back and just kind of analyze things here. In this first one, what is it that you have to do to get from one number to the next in regular consecutive integers? Stephanie?
Add 1.
Add 1. Okay. So you can probably guess that we're going to be dealing with unknown integers, which we usually use a variable for, right? So to get, let's say that the first unknown integer is x. Is it safe to say that with these, with consecutive integers, the next one would be x plus 1? Does that make sense to everybody? What would the next one be after that? X plus 2, x plus 3, and so on. Okay, so that's one way that we can go about these types of problems. Lots of other ways, but okay, how about this one? What do we have to do if I want to write a general sequence for consecutive even integers? How would it look? If the first one is x, the second one would be Jade? X plus 2, perfect. And how about the next one? Perfect, x plus 4, and we can go on and on and on. So if we're looking for 4 consecutive even integers, we could set the problem up using x, x plus 2, x plus 4, and so on. Is there anything different between consecutive even and odd integers in terms of a general sequence? No. So we can say x, x plus 2, x plus 4, and so on for this one. Okay, so here we go. Let's go through some example problems here. Ooh, I lost my cap. Okay. So find 2 consecutive odd integers whose sum is 160. Okay, so we're going to set this up in one way, but there's actually a trick to these that I'm going to see if you guys can come up with. Okay, 2 consecutive odd integers whose sum is 160. So is it safe to say that, again, since we're finding 2 of them, integer number 1 plus integer number 2 equals 160? Is that what sum means? Yes, okay. So how can we use the general sequence of what we started out with up here for consecutive odd integers in this expression? What can we do? What do you think? Josephine? Great. Good. So let's say the first integer is x. With consecutive odd integers, the next one is x plus 2, 160. And then now it's just a matter of going through and combining like terms, solving, and so on. Okay, so 1x plus 2x plus 2 equals 160. What would be the next step to solving this for x? Lydia?
I don't really know how you do this for there, but couldn't you, like divide 160 by 2 and then subtract 1 and add?
Yes. And that was the trick that I was going to wait to do. But yes, that's perfect. In fact, if you would like to come up and show that after we're done with this, that would be awesome. If you don't want to, that's fine too. But okay, so what would we do next to solve this equation for x? If we're continuing on with this one. Actually,
Subtract 2.
minus 2. So we get 2x equals 158. And then, what from there? Kendra. Divide by 2. So x equals 79. So if the first integer is 79, the second one has to be 2 more than that, which is what? So good, 79 and 81 are your integers. Now, I told you all there was actually a trick, a shortcut to these. That's actually really cool. And Lydia was mentioning that a second ago. So Lydia, would you like to come up and show that? No? No? Okay. Did anyone else catch what she said? Let's start there. Okay. You want me to show you the trick? Okay. Here, let's move this up a little bit. Okay. Is anyone still using this solution, or can I move it? Okay. Your silence is deafening. Okay, here we go. So, another solution is that what we can do is we can take the sum of the integers and divide it by the number of addends. Anybody know what addend means? What does that mean? Jared?
It's like one of the two things that adds up.
Right, perfect. And that will help give us like a midway point in some way. Okay, so what is the sum again of all of these integers? 160. Number of addends. How many numbers are we looking for? Here, 2. What is 160 divided by 2? 80. How does that fit into the two numbers that we ended up with? It's right between them. So what else about that? So 79 and 81, we subtract 1 and add 1 to this. What's that called again when you average the numbers? Mean. Okay, so this gives you the mean of the numbers. Okay? Questions on that? Yes? Yes. Yeah, so let's practice. Let's do another one. Okay. So let's do find 3 consecutive integers whose sum is 150. Ooh, someone just put perfume on? It smells really nice. For our viewers at home, it smells very nice in here right now. Okay, 3 consecutive integers whose sum is 150. Okay, do you guys, how about I can pause it and you guys can try it on your own and then we'll... We are back. Chaz is going to show us his solution to this. Go for it here.
Okay.
All right.
150 divided by 3
Good, so he's dividing 150 by 3.
50.
Good.
Then plus 1 and minus 1, so 49 plus 50 plus 51.
Excellent. How many people agree with Chaz? Woo! Excellent. Everybody give Chaz a round of applause. Okay, so now the question that I have for you guys, why is it the last one, I guess the question is, are we able to always just add 1 and subtract 1? Why is it the last one, each of the numbers was 2 apart? So it's 79 to 81. What was different about the last problem? That's good. Okay, so they were odd integers instead of regular consecutive integers. Good. Okay. Do we want to do another one of those, or are we good? You're good? All right. So let's do one that involves triangles. You all loved geometry, I know. Lydia.
For these, will it ever be like anything other than like odd, even, or
No. No, not this type of problem. That's what integers are, is they're next to each other in some way. Jared?
What is like the point of this? Like, what is it used for anything?
No.
Yeah, just do well on your math test.
That's true. To do well on your math test.
Yes.
So, yes. I love teaching Algebra 2. I feel the need to say that first and foremost. There are some things that we do in Algebra 2 that don't necessarily relate to life in any way, except that for those people who are going on to higher level math and science or have an interest in that, you need this groundwork to get there. How do you like that answer? Okay. That's good. Okay. Yeah.
I didn't just look at life, but like just do math. Like,
Okay. Okay, so one of the big things, what you guys will find, how many of us plan on going to calculus at some point? Okay, awesome. So for our viewers at home, almost everybody raised their hand. That's great. So the thing is, what happens as you go up in your math education is you start seeing problems that are a lot less like the solve this equation for x, or the ones that are very straightforward, and you start getting more word problems. So you have to be able to analyze them and break it down into something you know. So we're starting with problems that are a little bit easier to break down into what you know. But by the time you get to calculus, you're going to have like one word problem for your homework, and it's going to take you like 4 pages to solve. And you're going to have to be able to break down the information based on all the stuff that you do in this class. That's one of the biggest things that I remember from calculus is I would get all the crazy calculus stuff, and then he'd be like, okay, you have to factor this at the very end. It's like, oh, we did that so long ago. So it's, yeah, factoring, we'll get to that later. Okay, here we go. The sides of a triangle can be represented. The sides of a triangle can be represented by 3 consecutive integers. So it can be represented by 3 consecutive integers. The perimeter of the triangle is 162. Find the length of each side. Okay. Okay, so I'm going to pause it, let you guys work on it, and then we will come back. Come on, Marcy. Come on, Marcy, come on up. Marcy's going to come show us how to do this problem. So, the big question is, does the trick work on this one? And Marcy is about to let us know.
Marcy, I like your face.
Can you see me?
You can see you, yep, you're there. Okay.
Now you're not.
Am I supposed to be using this pen? This
That's
highlighter?
fine, you can use that.
Marcy, lean in. Lean in, Marcy.
There you go.
Okay.
No, lean in, Marcy.
What?
There you are.
Oh. What do you want from me?
Doesn't matter.
Okay, so okay, and then I did add them all together. 150, 712. So
Excellent. How many people agree with Marcy? All right, everybody give her a round of applause. Thank you, Marcy. Okay, so again, you guys are looking for whether it says consecutive even or consecutive odd, and using that to judge how many you have to add or subtract from your numbers, okay? Questions? All right, so let me put the homework up here so you guys have it. So, homework 5, page 28, word problems, numbers 4 through 9 and 15 through 17, and you want to study for your group test. tomorrow is your first group test. And it's on chapter 1. That would be tomorrow, Tuesday. All right, questions? Okay.